When we're doing systems by substitution, we have a couple steps that we do, and we do them the same every time. So we start with picking an equation and getting either x or y by itself. A lot of times these problems already have an x or y by itself, but if we have to rearrange, we're looking for the variable that does not have a coefficient. Remember that that's the number that's in front of x, right? We're going to substitute, which means to replace, substitute the value of the expression or value or expression of the variable into the equation not used in step 1. You don't want to rearrange something and then plug it right back into that. Solve for the value. So we're actually going to work through solve that equation, and then lastly substitute the new value of that variable into either equation and solve. The value or the equation with x equals or y equals is the better choice. You can always choose either, but the better choice is the one where it's already solved and you just have to plug it in. So here it tells us x equals 4y. So in the second equation we have an x. So step 1, choose x equals 4y to be our equation. We have x by itself, so that's our best choice. We're going to substitute that in. So we're going to replace the x. I always kind of put a skeleton there as a placeholder so that I can know where I'm plugging my pieces in. 4y is going to go into that spot. All right, now we're going to solve for the value. Multiply your 2 times your 4y, we get 8y, plus 3y equals 44. Combine like terms. 11y equals 44, and then divide by 11. Our y value would be 4. Okay. Now we're going to substitute the new value of x into either equation and solve. I'm going to choose the x equals 4y because x is already by itself. So I'm going to replace replace y with this 4 because we just said that y was equal to 4. 4 times 4 is 16. So we have that x is 16, y is 4. Remember when we're writing our ordered pair, the x goes first and then your y. So for example 2, same process, but here we have a y by itself. So it says that y equals 3x, and then we're going to be plugging that into the y spot. So choose y equals negative 3x. So I'm going to replace that. X plus 2y equals negative 25, but in place of y, I'm using this, negative 3x. Simplify, combine like terms, and solve. 2 times negative 3x is negative 6x. Remember, if there's an x with no variable in the front, it's a 1. So 1x minus 6x gives us negative 5x. Divide by negative 5, and x is positive 5. I'm going to go back to the same equation I used because that's the easier one to work with. Y equals negative 3x. So I'm going to replace my x with this value. Negative 3 times 5 is negative 15. So I have my x and my y. X goes first, y goes second. For the last problem, we still don't have to rearrange anything here. But if you look, the expression is a little bit more complicated. And they're in a different order. Here, it does not matter what order they are in. You can see that you have your y equals, even though that's the second equation, that's still the one we're going to choose. Right? So when I'm going to substitute it in, I'm replacing my y. So 6x minus 2 y equals negative 4, and I'm going to replace my y with this whole piece here, with that whole x minus 4. Now when I simplify and solve, I'm going to have to distribute because I have two pieces inside my parentheses. I have to do the negative 2 times x and the negative 2 times negative 4. So I have 6x minus 2x plus 8 equals negative 4. Combine like terms. This is a two-step equation, not just a one-step. So we first get rid of our adding or subtracting piece. We'll subtract 8. I'm going to go up here so that I don't run out of space. And then I'm going to divide by whatever is in front of my x. So my x is negative 3. Go back up to my equation, y equals x minus 4. I'm going to replace my x with this negative 3. Negative 3 minus 4 is negative 7. Once I have that x and my y, I write my ordered pair and my problem is finished. Negative 3, negative 7, that's my final answer.